the first retake that I offered you guys, and I want to actually work out the solutions to this too, just so you had some more to practice with. So, a scalar is actually a quantity that only has magnitude, and magnitude, of course, means size. In other words, things that are scalars are basically plain old numbers, is really the way to see that. So, which of the following is a scalar? Well, this is a vector, vector, vector. Time is a scalar. It doesn't have direction, meaning it doesn't. You can't talk about it like 3 o'clock northeast or something like that. It's just weird, right? So, when we talk about the initial position of an object, what we mean is an object's position, when the timer starts. It does not mean 0, okay? Not 0. Let's be clear on that, so memorize that for the final. Now, 1 lap around a track is 400 meters. If a person runs 4.5 complete laps around this track, what is the person's displacement? So let's think about this. Here's a circular track, okay? And what we're saying is this. We go from here. There's 1, 2, 3, 4, and half a lap means here. So this is x initial, this is x final. That displacement is x final minus x initial. Well, that's the diameter. So I actually threw this question out on the retake because the correct thing to say is that 400 divided by pi would actually be the displacement. None of those choices are on here, so I actually threw this one out. So if I were to actually make these correct choices, what we'd have is that this would be 0, 400 over pi, 800 over pi, and 1600 over pi, because you actually have to use the diameter of the circle. And I would not put something like this on the final. Now, number 4, we want to know which object has the smallest speed. Actually, C and D, because remember, like in the previous exam 1, not the retake, but the one that you do before this, just the plain old exam 1, we said that speed is the magnitude of the velocity in one dimension, so these have the same speed. Okay. Now, once again, we're saying here east is positive, west is negative, so this is positive, negative, and this is x versus time. So what's the person doing in this graph? They're starting east and walking west because there's a negative slope. A negative slope, we've defined east as positive, so that means this negative slope means we're moving west, even though we started off in a positive way right there. Right? So now, what is the person doing in this graph? They start east, they're moving west, and they actually walk past the entrance. But it's accurate enough just to simply say that we start east and we're walking west, so B actually works again too. Now, what's the person in this graph doing? Here's X, here's T. They're just standing there east of the door. And then what's happening in this position time graph? B is moving forward slowly. Again, not a steep slope. And A is moving backwards quickly. So actually, let me just kind of make that a little bit neater. So again, B is moving forward slowly, and A is moving backward quickly. So what this means, again, is forward is east, backwards is west. So let's see if we can find that. So it's interesting. All the choices offer us that A and B are walking in the same direction, and they're not. So none of these is actually the right answer. Now, what happens in this graph is that A is walking west, B is walking east. Again, looking at the slope. So actually, they're walking in the opposite direction at about the same speed. And what's happening at point P is they pass each other at the entry to the SLC in this problem, right? So now, number 12. There's a couple. Actually, there were a number of choices that I accepted with this one. So it says someone starts at the entry to SLC and walks east. Actually, no. For this one, there's only one choice, and that's A. Now, which is a position versus time graph for someone standing still east of the doorway? Let's see which choices work. So that would be choice E right there, because this is east. And remember, flat position versus time graph means no moving. That's how that one works. Right? Um, which one is a position versus time? A and B standing still with A further east than B. Standing still means this would work, and this would work. These are all actually true because they're all standing still. And each one of these, you see that the A line is on top of the B line, which means it's further east than B. And here, position versus time graphs. We want to get the velocity. Again, just like in the previous exam, let's get the slope. So V is going to be x2 minus x1 over t2 minus t1. So let's go ahead and calculate that. So x2, that's going to be, you know what, I'll make it negative 60 at 10 seconds. And I want to subtract my initial position, or a position that I can actually read. And as I recall, I actually had this as 10 seconds. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can actually see where my position is at 2 seconds right here. So what I'm going to actually say is that at 2 seconds, my position is in fact 60. So what I end up getting is negative 120 divided by 5. So what I end up getting is, if I have this right, negative 24 meters per second. So with the object's position at 10, negative 60 meters. Now, its distance from the starting point, that's actually a tricky way of saying displacement. So if you look here, this is actually 90 right there that we start at. The way this would work, again, so we would have here distance to the origin after starting. What they're really asking for is a displacement. So delta x is going to be x final minus x initial. And that's going to end up being negative 60 minus, and I start at 90. So that ends up being negative 150. That's my displacement. If you don't get the distance, you take the absolute value of that displacement, and you get 150 meters distance traveled. Okay? So notice, this is my velocity, and if you look here, this is my initial position. And this relates to our next question. So get these kind of highlighted or circled or whatever you want to do, because in the very next question, they ask us for the equation. And using the logic at the last test, we use x equals v naught t plus x naught. And we have x equals negative 24t plus 90. So we want to know where the thing will be in 15 seconds. Use the same logic as the last test. Negative 24 times 15 plus 90. And we actually go ahead and calculate that. So that'll be negative 240 plus 100. Plus 120. I'm doing a little math here in my head, so you're just going to have to bear with me. So that's going to be negative 360 plus 90, so that'll be negative 250 meters if I did my math right. Okay? So that's what I get. Now, here. This is an interesting problem, and actually let me just check how much time I have. Good. So this is actually an interesting problem because what we have is the cop and the car situation, but now they're moving towards each other. So what that means is that this is going to be negative and this is going to be positive. So when we actually draw this graph, what's going to happen is we have position versus, you know what, I don't like this color. Let me draw the axes here in black. So I have position versus time, and we're going to do the same thing. I'm going to make the secret agent a blue dotted line. And I'm going to make the bad guy a solid red line. So here's what happens. The secret agent starts moving like this, but the bad guy is moving backwards, and they meet here. That's what happens with this graph. And what actually happens is that the secret agent is, in fact, moving. So I actually have this graph wrong because the secret agent is moving. No, I have it right. The agent's moving faster than the bad guy. The secret agent's moving at 20 meters per second, so it should have a steeper slope. And the bad guy should have a less steep slope. And if you notice, we're not saying anything about the numbers, we're talking about direction there. But the steeper slope is steeper, and that means faster, and the less steep slope means slower. Now notice this slope is less steep, but it's negative, which means it's moving backwards, and the steep slope is steeper, and it's positive, which means it's going forward. So I can tell which car is moving faster because faster car equals steeper slope. Now, I'm going to write down the equation of secret agent's position as a function of time. So it's actually going to be x of the agent equals 20 times t. And now here's where people mess this up. X of the bad guy is going to be negative 10t plus 600 because it's moving backwards. So to get where things end up, you use the same logic as the last problem. You set these equal. So when we go ahead and do that, what we're going to actually end up getting is that x of the agent equals x of the bad guy. So we're going to get 20t equals negative 10t plus 600. And so we're going to end up getting they meet at 600 divided by 30, 20 seconds. And where they meet, I can actually do xa equals 20 times 20, and that's going to give me 400 meters is where they meet at. Okay, so very similar logic to that first problem. And that's kind of how you get those answers. Okay. Let me make sure my writing's okay. So that looks good. All of this looks good. What I noticed in the last exam solutions that I did was that my work got kind of moved out of the way a little bit, and it couldn't be seen. So I just want to kind of make sure that you can read my stuff when I print this up and put it in a PDF file for you. So that's all I'm doing here. So put all that there so that it can be seen. Nice. There we go. There we go. Nice. All right. Now, moving along. I think what I'll do is do this last page. How much do I have? Now I'll try to finish this up in this video here. So again, here we have a bird flying 20 miles in 45 minutes. How quickly is it flying? Again, 20 miles divided by 45 minutes. You know what? I'm going to use some common sense with math. This is 20 divided by 3/4 of an hour. So that's going to be 4 times 20 divided by 3. So that's 80 divided by 3. And when I get that answer, 80 divided by 3 is 2 times 3. So 26.7 miles per hour. So if you couldn't follow that math, I'm sorry, 45 minutes is 3/4 of an hour. I expect you to be able to do this is 5th grade math. I expect you to be able to do it. Now, you look down at text for 0.5 seconds and travel 110 meters. How many miles per hour are you traveling? So let's see. I travel 110 meters in 0.5 seconds. So this actually gives me 220 meters per second. Let's get that in miles per hour. So 1 mile is 1609 meters, so that cancels those units. And then 3,600 seconds is 1 hour. So now I can use that to get my speed in miles per hour. This works out to like 492 miles per hour. So I guess we're like on the bullet train or like somewhere in Las Vegas doing some crazy stunts. So that's cool. Now, 4.5 meters around a 4.5 meters on a 400 meter track in 13.5 minutes. What distance do they run? Well, that's 4.5 times 400. So that is going to end up being 1,600 plus 200, which I think ends up being 1,800 meters. We're going to know their displacement. Their displacement is going to be from here to here. So that's actually half the circumference of the circle. So the track's 400 meters, so that's going to be 200 meters displacement. The average speed is going to be 1,800 divided by 13.5 minutes, and I would be okay with this on the final, unless I told you I wanted a specific unit. The average velocity is going to be 200 divided by 13.5 minutes, and in the interests of time, I'm going to let you work those out for yourself so that I can end this video and you have the solutions to exam 1 retake.